Hey everyone, Aditya here. So today we are going to learn about AWS Lambda. AWS Lambda, it's a serverless world. So AWS Lambda is a new trend and we can say it's a new paradigm. So we will start our serverless journey using AWS Lambda. So AWS Lambda is becoming very popular and one of the most widely used serverless service within the AWS. It has revolutionized how people develop applications and deploy them and scale them to the large extent. So it is very important to know about AWS Lambda and how to configure it and how to use it very properly. So this course or this tutorial is not just a high level introduction of the AWS Lambda. We are going to learn in depth the things of AWS Lambda in a real world fashion. So without any further ado, let's get started and code our first Lambda functions. So now we will get a question arises. What is serverless? So to answer that, this serverless is a new trend and we can say new paradigm in which we deploy applications in a serverless environment. So we don't need to manage any servers here. So this will gives us a flexibility to just deploy our code. So you just develop and deploy the code and whatever servers it has to manage, it will be done by AWS. You don't need to do anything. So it was managed by that cloud provider. So what is the concept of AWS Lambda is fast, that is function as a service. So this was the basic idea behind the Lambda. So serverless initially started by AWS Lambda, but now everything in AWS is becoming an serverless architecture because everything which was managed by AWS is called a serverless. For example, you can take database, you can take storage, and you can take messaging, etc. So now we will see what are the different serverless services available in AWS. So before that, we will see an high level real world scenario. For example, we have users from different parts of the world. They want to log in and they don't want to manage servers for their login services. So they can opt for Amazon Cognito service. And we can use, if you want to use any serverless REST API, then we can use AWS API Gateway. If we want to deploy a website without using any servers in behind, we can use AWS S3. We can use AWS S3 static web content. And if we want to do some messaging kind of thing with we can use AWS SQS, which is in again another serverless service in AWS. And if we want to finally store the information into a database, we can use DynamoDB, which is also managed by AWS. So it's a serverless. So these are all the serverless services available in AWS. So now we'll see what are the serverless in AWS. We have AWS Lambda, the first and foremost, and the DynamoDB, AWS Cognito, AWS API Gateway, Amazon S3 for storage, and SNS and SQS for messaging and notifications. And we have AWS Kinesis Data Firehose also is in serverless architecture because the throughput is managed by the AWS. And so don't get overwhelmed. Few of the service, most of the services we didn't look at it, but I am just explaining these services as an examples of serverless architectures and serverless services available in AWS. Few more serverless services in AWS are we have Fargate, which was easiest managed service, and we have Stuff Functions, and we have Aurora DB. So these are all managed services in AWS, which are serverless. So we don't need to worry about software as a solution kind of things for us from AWS. Now we will see what is AWS Lambda. So why we need to use AWS Lambda? Okay. So let us take an example by differentiating between both EC2 and Lambda. So first take EC2. So what is EC2 and how it works? So EC2 is a server in the cloud. Okay, it is nothing but it's a virtual server. But all the configurations we have to manage. So whenever you spin up a EC2 instance, you have to set what is its instance type, like memory, size, everything. We have to configure by ourselves. So that server we have to manage. EC2 configuration is based on instance types, right? RAM and CPU are limited. For example, if I take a lower instance type, the RAM will be less. For example, a 2 GB and CPU will be 4 CPU. and if you want to increase them, it will be limited. So you have to use another larger instance type, right? And so increase that instance type, you have to terminate your EC2 and you have to again spin up a new EC2 instance. That means a manual intervention definitely needed. And one more thing is the EC2 instance will run continuously until and unless we have to specify to terminate. Otherwise, the predefined functionality of an EC2 is if you run it, it will execute continuously. And with respect to scaling, by default, EC2 is not scalable, right? You need a manual intervention. If your traffic is increasing, you have to increase your EC2 instance by stopping it and increase to another. Uh, Maybe it's maybe vertical scaling or horizontal scaling is based on our preference. And we have another service like auto scaling groups which will integrate with EC2 to scaling, but that too we have to specify manually. It's not included within the EC2. We have to configure that auto scaling group also manually. Now we'll take a look at AWS Lambda. So when it comes to AWS Lambda, in AWS Lambda is not like EC2 instance. AWS Lambda is a function provided by AWS. So it's as simple as like a function. So no need to configure any servers here. Just write your custom code and execute it like a function. For example, in our code, we write some functions, right? Like that, you can write your code inside the AWS Lambda and execute it. That's it. No need to manage anything. Like you don't need to, for example, you take Java. You don't need to create your JVM and install the JDK. Those and all, you don't need to do anything. So you just write your code and configure that code. There was an option which language you are using. Select that language and execute your code. Everything works like a magic. And there was a limit in Lambda execution time which was not there in EC2. For example, the AWS Lambda has a hard timeout of 15 minutes. So after 15 minutes, AWS Lambda will terminate by itself. Okay, so no need to worry about the termination of AWS Lambda. So we need to ensure that our application execution has to be completed within this time limit. So this is one of the limitation and merit for some applications also. Right? If you want to terminate your AWS Lambda within 15 minutes, this was the best use case. And by default, AWS Lambda is on demand. So that means no need further configuration to make it on demand, and you have to pay per use. Now, the scaling of AWS Lambda is automated. Unlike EC2, no need to use any further service like auto scaling group to scale. Even Lambda provides to execute the application in multiple concurrent instances of Lambda. For example, you have a function, a Lambda function. You want to execute that same Lambda function in multiple instances. Instances in the sense is not EC2 instances, an instance of the Lambda function. So I have 10 Lambda function instances. We can concurrently execute them. Now we will take a look at of AWS Lambda support for different programming languages, right? AWS Lambda supports for Java 17 up to compatible up to Java 17, and we can use Java 8, Java 11, and Java 17 also in the latest AWS Lambda. And we support C Sharp and PowerShell. We support Node.js, Ruby, Golang, Python, and also we have custom runtime API of AWS Lambda. Using this custom runtime API, we can write our code in any other languages. For example, your language is not in this list, then you can go for custom runtime API, and you can use that custom runtime API to write your code inside and execute as a Lambda function. And also, AWS Lambda provides Lambda container images. So, if you take an example of ECS and VCS with Fargate, so Fargate is a serverless architecture, and we'll discuss about Fargate in the further lessons, but don't worry about it. So Fargate is a serverless uh, Kubernetes service provided by AWS. We can say it's a managed Kubernetes service by AWS. So inside we don't use any serverless, any servers. So inside it uses the containers. So since Kubernetes runs Docker images, right? It's a serverless architecture. In turn, it uses a Lambda. So if you are using any container images to run Lambda, it must implement that Lambda must implement the custom runtime API. For example, this Fargate. So Fargate is a serverless way of executing Docker images. So it in turn uses this Lambda runtime API to run those Docker images in the Lambda function. Now we'll take a look at of merits or advantages of Lambda. The first and foremost, we look at the pricing. The pricing is pay per request. So you have a Lambda function. How many times a request hit that Lambda function, based on that we have to pay to AWS. So here we can see the free tier covers up to 10 million AWS Lambda requests and 4 million GB of compute. So we can use this free tier limit for one Lambda function. So if your Lambda function reaches this limit, we can terminate it and again terminate it and again up another Lambda function. So likewise, we can uh, keep our Lambda function in the same pricing limit, free tier limit. And it has integrated with a lot of AWS services. So Lambda function is integrated with most of the AWS services. That was a very good advantage for us. And also we can increase the compute resources per Lambda function. For example, we can increase the RAM up to 10 GB. So by increasing RAM, which helps us to improve the compute and network also. Okay. And we have integration support to a lot of programming languages. As we discussed in the previous slide, we can integrate with lot of programming, well-known programming languages, and also you can write your custom code if the programming language is not in the list. And with respect to monitoring, Lambda integrated with AWS CloudWatch. So Lambda, whatever the logs Lambda writes, it will send to the AWS CloudWatch, and from the AWS CloudWatch we can monitor the logs. Now take a look at a few services below having integration support with AWS Lambda. So for example, Amazon S3. So S3, how it integrated with AWS Lambda. So if you put an object in an S3 or create a new object or delete an object, or if you modify any object, right, we can set up S3 to send a notification to AWS Lambda by using some other intermediate service like AWS Event Bridge. So we'll discuss about later. So any event in the S3, we can send trigger in AWS Lambda. So what is this AWS Lambda? You can write any custom logic, like someone creates a file. So AWS Lambda will get triggered and read the file name and send a notification to team, like someone created this object, like that. And AWS Event Bridge. So AWS, sorry, and CloudWatch Event Bridge. This CloudWatch Event Bridge is the main place where all the events has been stored in our AWS. So in our whole AWS infrastructure, for example, S3 and any other AWS services, any event happen, we can configure CloudWatch event to listen to that event. Okay, so any events happen in any services comes to CloudWatch event bridge. Now the CloudWatch event bridge will route this as triggers Lambda functions for each event, right? So if it triggers a Lambda function, it do some custom processing based on the requirement and send back the response. And finally, DynamoDB. So in the DynamoDB, if we have any record inserted, modified, deleted, any event happened in the DynamoDB, we can trigger a Lambda function, and Lambda function will process the custom code. Maybe we can notify to the team whether someone changed your database. Similarly, we have other services like AWS CloudFront and AWS Cognito and AWS API Gateway, SNS, SQS, Kinesis. So any events happen inside these services also, we can trigger AWS Lambda, and it will process some custom code to send notifications, to send response to some SNS or SQS, which again send notifications to the respective team. So like that we can create integrations with these services with AWS Lambda. Okay, now we will look at different architectures we will build using this serverless technology and also using AWS Lambda. Now, the first example I'm going to take is serverless notification system. Now I will explain what is this serverless notification system. We have an S3 bucket and we are inserting objects into the S3 bucket. Like I am inserting some files, text files. So once I inserted those files, S3 triggers an Lambda function. So the functionality of this Lambda function which process the created object and opens the file and count the number of records and also get the file name, file size. So this kind of metadata information Lambda processes, and also inside the content it will count all the records. How many records are there, that count. So that information Lambda will process for us. Once this custom logic processed from the Lambda, it will trigger SNS, a notification service. So this SNS topic will take the information from the Lambda and send a notification to the users. So someone created a file in the S3 bucket with this much with this name and this much of record length. And also the same SNS topic we we can configure to store this information in a serverless DB, that is DynamoDB. If you see here, the S3 bucket, AWS Lambda, Amazon SNS, AWS DynamoDB, these are all serverless architecture which are fully managed by AWS. And we'll look at another example in AWS which uses this serverless architecture, which is scheduling jobs serverless architecture, that is cron. So we all heard about cron. Cron jobs are scheduling jobs. For example, I want a job to execute for every 1 minute and I want a job to execute for every 1 hour. I want to execute job from 12 p.m. to next day 4 a.m. So like that, we can schedule the jobs using this cron. And how AWS Lambda is going to help us in this architecture is we are going to create an CloudWatch events bridge. So in CloudWatch event bridge, we have an option to enable the cron job. So for every 1 second or 1 minute, we can trigger an Lambda function. So for every 1 minute, we get a Lambda function. That Lambda function process some information from the database or somewhere, and it's to its custom logic. Similarly, we can create another rule in the same event bridge and ask for every 30 minutes process another set of files. So this is how the CloudWatch event bridge and Lambda both will provide the flexibility in a serverless architecture of executing applications in a very efficient manner. So the CloudWatch Event Bridge and AWS Lambda can be used to get a serverless cron architecture. Now we'll have a look at up AWS pricing. We have already seen that AWS Lambda charges based on the request we used. So paper requests, and we know the free tier itself covers 1 million requests per month. So if we didn't exceeded for a particular lambda 1 million requests, then we are under safe zone. So we are in free tier. But if you are exceeding that 1 million requests, then after 1 million requests we need to pay for $0.2, and thereafter we need to pay this amount. Okay, now we can also pay based on the duration, right? So first thing, the free trial covers 4 lakh GB seconds of compute time per month and 4 lakh seconds. So if we configure our Lambda function as 1 GB RAM, it provides 4 lakh seconds of compute time. So once we breach these values, then we have to pay $1 for every 6 lakh GB seconds. So since you see most of the works we can manage in the free tier itself, right? Free tier, and based on the requests also, based on the duration also. So that's why AWS Lambda is becoming very popular AWS service and very budget friendly AWS service, which makes everything hassle free because we don't need to manage any servers using this serverless architecture. Kudos to AWS. Okay, now it's time to do some hands-on. So I am open my AWS account. So from this home screen, we have the search bar, right? I'm going to search for Lambda. So once you open your Lambda UI, if it is the first time, you will get this page. So here Lambda AWS Lambda is a part of compute resources, and here they mention let you run code without thinking about servers. So no servers, only running your code. Okay, and you pay only for the compute time that you consume. There is no charge when your code is not running. Very good. With Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Now here, if you below see this, how it works, the AWS console itself is giving this uh, thing. So how it works, it is showing, right? You have a number of programming languages as we discussed here. So Python, custom runtime also we have available. For example, I think this is the code for Rust, and AWS is providing this thing, right? This custom runtime for the Rust also. And now I'm going to Java. So this is the Java code we need to implement, right? This is the Java code. The example has been given. So here what is happening, this is simple hello. So what we are doing is we are saying hello from the Lambda. So it's a simple Java code. Now we'll see and click on this run, what will happen. So if I execute this, hello from Lambda is displayed on the screen like this. Nice. So without any setup of server and installing Java, JDK, JVM, this and all, we just executed the Java code without anything. This just UI, right? I clicked on run and it's running and it's printed the Lambda without installing any Java related packages and without maintaining any servers. So that will be a good thing. So we have this nut symbol. We'll try to explore this. Okay. Here it's showing how it works. Okay, we'll see. Lambda respond to events. Okay. Once you create Lambda functions, you can configure them to respond to events from variety of sources. Oh, nice. So try sending a mobile notification, streaming data to Lambda, or placing a photo in S3 bucket. So here, the AWS console itself provided three types of examples. One is from here mobile, we can send data. That send data will go to this mobile or IoT packet is nothing but some API gateways or internally EC2 instance, for example. If I send one message, it will go to this mobile IoT backbones and it hitting the Lambda functions. So I'm going to send one more request, and whatever I send the request, it will go here and it will process like this. So hello from Lambda, right? And we have streaming analytics, for example. There is a live stream and we are sending stream of data into Lambda. Yes, we can do. I can send n number of data, right? Look, I'm sending how much amount of work, and every if based on your request, Lambda will create its parallel executions, concurrent executions. For example, I'm sending these many requests, so that a Lambda is scaling automatically by itself without configuring anything, right? You don't need to manage scalability also. And I'm trying to send more photos. So I'm uploading more photos to S3 bucket. For example, this is S3 bucket, and if you see for data processing purposes, we are invoking the Lambda, and this Lambda is creating n number of instances of the same Lambda for parallel execution without configuring anything. Right? You just configured your AWS Lambda. That's it. And the remaining thing you have configured your source and the trigger. And from the trigger, Lambda is invoking, and without any configurations, it is scaling like this. And from the mobile, We can set an n number of messages, and Lambda will execute those n number of messages using these concurrent threads. Okay. Now we have another option, scale seamlessly. Yes, we can scale seamlessly. Now we'll see how it works. If you see here, based on requests, right, the invocations, the cost is there. So as we discussed, for 1 million to 1 million requests, there is no cost of it. Now we'll try to send more. So now it crossed the 1 million. Once it's crossed the 1 million, if you see, the cost is going to increase, right? And I will go to increase furthermore. So based on after 1 million of your free trial, you are based on number of requests for your Lambda invocation, you will be charged like this. So Lambda scales up and down automatically to handle your workloads, and you don't pay anything when your code isn't running. So if your code isn't running, no need to pay anything. Okay, your first million requests are first 4 lakh GB of seconds of compute per month are free. Costs in this demo are based on 128 MB function with 1 second invocation duration. So that means every 1 second this lambda is invoking, and also the function has been configured with 128 MB of RAM. So that's why you can see after 1 million is getting a cost is going to increase, right? So okay, now we'll try to create a lambda function and see what are the properties configurations available inside the lambda function. So I'm clicking on this create function. So here we have this tab open, and if you see this window, create function, and choose one of the following options to create function. Okay, we have three options here. One is author from scratch, so we can write our own scratch lambda function, or we can use a blueprint. So build a lambda application from sample code and configuration presets for common use cases. So this is the best for us because it will create a sample code for us. After that, in future, we can use that sample code to enhance to our big application. And you can run container images, as I mentioned, right? Container images also. So we can run container images in Docker. So as of now, I'm going to use a blueprint because it will give some sample code for me. So blueprint name is, here we have some blueprint name for different programming languages. Okay, and if Java is not there, we'll try to create using Python. So hello world function Python. Okay, and we can give our function. So for basic blueprint, the Java application is not available here. It's searched everywhere. So that's why for basic blueprint, I'm using Python. So it's configured for Python 3.10. Okay, function name. We can give some function name. Demo lambda learning. Okay, and it is using Python 3.10 runtime, and this is the architecture 64-bit and execution role. So here, when it comes to execution role, you can use an existing role, or you can create a new role using the policies template. But I am going to create a new role with basic lambda permissions. Okay, so this UI itself will create an role for us. No need to worry of to creating role manually. But if you want to create, or if you have any existing role, you can use here, like selecting here and providing that role AR. Okay, so Lambda will create an execution role named something with permissions to upload to Amazon CloudWatch. So why this execution role? So whenever you execute a Lambda, it will create logs. Those logs will be sent to the CloudWatch logs. So as we discussed earlier, okay. And Lambda function code. Now look at Lambda function code. Here, this is the Python code. If you see here, we have this Lambda handler method, and we have this printers. So it will log these values. So what is the key 1, key 2, key 3? And so the event is an object. So in that object, we are passing these three keys. That is fine. And finally, we are returning key 1. So that is nothing but the first value in the event. Okay, fine. Now I am going to create this function. Okay, click on this create function.
So now it's trying to create my Lambda function. It is taking some time, seems my internet is slow, and yes, my Lambda has been created. So this is your first Lambda function. There you go. So you have this diagram tab turned on so that your Lambda will be visible like this, and you can add any destination from this Lambda to send a response to some destination, and you can add any trigger. So if you add a trigger here, from this trigger we can invoke Lambda. From this Lambda you can send to any destination. So these things we can configure, and I will click on template. Okay, template will show some YAML configuration of the same Lambda function. Okay, fine. So it's given its application resource name. This is ARN. Nice. Okay, fine. We'll see. We'll scroll down. Yeah. Here, if you see, right, we have code section. In the code section, you can able to see our uh, code, the hello, the basic Python code, right? And you have so many options here like test, monitor. You can add configurations here, right? So you can test your code by using this test events, and you can monitor. So how to monitor, right? Once you are once your Lambda execution started, you can see uh, these things and configuration. We can configure the Lambda. As of now, it's configured with basic 128 MB memory and 512 MB ephemeral storage, and few timeouts and all. And we can edit this general information, and we can add triggers. So from what is the source which trigger this Lambda, and we have this permissions tab. So if you see here, it is integrated with CloudWatch. Like this, you have a number of options. Okay, and we have alias versions. So as of now, no versions. Okay, now we'll go with one by one. So if you scroll down, you have this code properties also. What is the package size? This is the size of your code, and its hash value and last modified information. And runtime is Python. What is the handler name and what's the architecture? Even we have this runtime management configuration which shows the ARN and runtime version. Okay, and after that we have layers. Okay, so without any further ado, we'll try to test this Lambda function. So this is a Lambda function. We can invoke it from any source, or we have this test functionality in the console itself to test your Lambda before deploying. So I'm clicking this test. So I once I click the test, I got a response value 1. As you see in the Lambda function, we are returning event of key 1, that is value 1. Okay, and also we have some logs, right? Loading function and its request ID, and what are the value 1, value 2, value 3. So that is what we mentioned in the print statements. And it's reported some duration, so how much time it took complete, and what is the build duration. So it's built for 2 milliseconds, and which memory we are using, and maximum memory from 128 MB, how much you utilized 36 MB one. And yeah, so how much time it takes for initialization? It takes 165.86 milliseconds to initialize. So these are the information is displaying in this execution results. Okay, now what if you want to change this Lambda function? For example, I am going to print another value. So I'm going to print some value like hi. This is and in the event I'm going to send my name. So as a key 4, we'll see how it works. Okay, before that I need to change the event. For that we have this option called test. So go to test, and we can create a new event, and we can name it as. So this, so I'm creating my event, right? I'm giving some name, display my name, and it's a hello world only. Here in the key section, I'm going to add one more key, that is key 4, and with my name, and yes, that's it. So we can save this. Okay, there will be an issue. Okay, I need to add some comma here. Yeah, just an issue. Okay, I'm going to save this. Yeah, it got saved, and I'm going to test code. So in the code, before we have made a change, right? Before going to test it, I need to first deploy. Here it's showing changes are not deployed, right? So once deployment completed, that means your changes has been reflect in the test. Okay. Here, if you see, I have given key. We need to give key 4. Okay. Now again, I am deploying the code. Deployment has completed now. We'll see how it works after clicking the test. Boom. There was an error. Okay, what is the error? Key is the issue. So we have given key. Okay. I'm going to check here. We have given key 4, no? So, oh, before that, we need to select which event. Not we have display name. This is the event we created. I am selecting this event, and again I am trying to execute. Even it's failing. What is the issue? It is not taking key 4. Why? I am going to test and check. I have given key 4 here, and in the code, are we given key 4? No, we have given key only. Oh, nice. So again, I have given key 4 and trying to test or deploy the changes before testing. Once deployment completed, I am clicking on this test, and if you see, still it's printing value 4. But in the function logs, right, this is response. But in the function logs, if you see, my name is displaying. And if you want to display here, you can change to response. You can change to key 4, and again deploy and test it. If you see here, my response name is Aditya, and the function logs has been printed as usual. And here you have another option to raise exceptions also. For example, we can raise an exception like this. So this is all Python code. So I'm going to deploy this again. I'm going to click on the text again. So if you see, the exception has been raised, and that is raise exception, which is the custom exception we have raised for Lambda. Okay. Now we look at different things, right? First, we have already seen test. We'll see a monitor. So what is happening here? So if you see in the monitor, you can see we have this number of invocations. So this tab shows to invocation. How many invocation happened? Okay, we have from this point of time. Initially we have one invocation. After that we have two invocations. Okay, and also duration. How much time the invocation executed? The first one executed for 1.25 seconds, it seems, and milliseconds, and after that the second one executed for more time, right? And we have error counts. So how many times we got error, and green is the success percentage. So green has 100% success rate, and we don't have any errors as of now. But we got two errors. Okay, what is those two errors? Also, we can see it seems nice. So we have throttle concurrent executions. As of now, we don't have any concurrent executions. Uh, Seems we have one execution. So and we have this throttle, and like so many options available here. Okay, and for traces we can integrate with X-rays, and if you see here, this is our CloudWatch logs, right? CloudWatch, since Lambda is integrated with CloudWatch as we learned earlier, the logs has been displayed like this. And so these are the latest streams. So this means 1, 2, 3, 4, 5 times we invoke the Lambda, so that 5 log streams has been created, and also it's showing GB in seconds, right? So if you see here, how many build duration in milliseconds, and what is the memory we set in MB, and what is the build duration in GB seconds, right? We haven't used that much, so no need to worry of this. And the next section in the monitor itself, right? We can see our logs in CloudWatch also. So if I click here, it will open the CloudWatch console, and from the CloudWatch console, it will open the demo Lambda learning. And if you scroll below, you have this log streams, right? In the log streams, you have a number of streams has been created. So each stream is an log of each invocation. So I will take the latest stream and check the logs. So if you see here, this is the latest stream. So this, if you see here, Python 3.10, we are using this lambda, and after loading the function, this is just request ID, and these are the logs. So value 1, value 2, value 3, and hi, this is Aditya. And there was some exception in this POFL, and that is something went wrong, right? And yeah, so we have raised an exception rate in our last invocation, so that is something went wrong and reported. So build duration, memory, and all. Okay, so like this, the AWS Lambda is automatically integrated with CloudWatch. We don't need to worry about it. And we can change the configurations, right? As I mentioned earlier, we can update this memory by clicking edit here, right? We can update up to 15 GB. So I will try to add 15. Okay, so in memories, we'll try to add 1024 MB. Okay, 1024 MB. I will try to add more than that. No, we can't add more than that MB. 10240 is the highest. And we can increase this ephemeral storage. We can increase up to 10 GB. Okay. You can add the snapshot. Okay, I don't. And which is supported for 11, Java 17, and Java 21. Okay, fine. And timeout. So when it comes to timeout, we can increase the timeout also. For example, we here it sets for 3 minutes, but we can include maximum value to 15 minutes. So after 15 minutes, we can our lambda function will automatically terminate, right? This is the service role which was created by lambda itself, uh, existing role, and we'll see what it's created for us. So this is the role created by lambda itself. So it has creation date, ARN, and all, and we have these permissions. So I'm not going deep here. I'm just opening what are the policies available here. So it is an AWS Lambda basic execution rule. So if you see here we're mentioning hello, create log group. Okay, and after that we're allowing create log streams and put log events. Mm, put log events. So like this, we're saying. So we're configuring it for CloudWatch, right? And I'm coming back to my Lambda. Yeah, so that is about the basic edits. And if I come back, we have triggers. You can configure your triggers from which source you want to invoke your Lambda. So here we have a number of triggers, right? Look, these many triggers we can configure. The famous ones are API gateway, load balancer, load friend, and event bridge, right? You can invoke Lambda from event bridge S3, SNS, and SQS. So it was very nice feature, I can say. And you can configure your destinations like this. So Lambda will process and send a destination to SNS topic or SQS queue or another Lambda functions. So like that you can add destinations and the function URL, environmental variables. You can add environmental variables tags. You can specify your VPC. So if we have so many details here, you can specify the database also. I think RDS database connections, but fine. So these are the things basic things we need to know about Lambda functions. Okay, and this Lambda function won't be charged until it was invoked, right? And first 1 million requests are free, so no need to worry about this Lambda. Okay, so thanks for watching my videos. Do like, share, and subscribe. And I'm putting so much efforts to get good content. So this is start of my YouTube journey. So kindly support and let me know if I need to improve anything. Thanks for watching.